Earlier, I said that ANOVA is regression by another name, and that's basically true, but you've only learned about the simplest kind of regression so far. So you've also only learned about the simplest kind of ANOVA, the kind where each observation is assumed to be independent, there are no random effects, and no nesting, etc. So much of what I've said here is specific to what you might call between subjects ANOVA. There is also repeated measures ANOVA, for example, and that's a different story to be covered another time. When we're talking about regression models that have interactions in them, type 2 main effects are tested adjusting for one another. In other words, this approach is similar to fitting one regression model with only main effects, saving the interaction for a separate model. This is my preferred approach, and it's also the default for the A ANOVA function from the CAR package. Type 3 main effects are tested in the same regression model as the interaction, meaning that they are actually conditional effects or simple effects rather than true main effects in some sense. Some implementations automatically contrast code or center your predictors to estimate these conditional effects at useful points, like the average of the two conditions possibly weighted by sample size. The default approach in SPSS is type 3 with contrast coding, where the main effect is actually a conditional effect at the precise midpoint between the values of the moderator. The ANOVA function from the CAR package has no such default for type 3, so the user must set up the desired main effects in the regression model before even passing it to the ANOVA function. If you try type 3 without setting up special contrasts ahead of time, you'll just end up with f-tests of the same simple effects or conditional effects within each of your categories that you would have gotten from the normal regression summary. With all this talk of type 2 and type 3, you might wonder what type 1 is. Type 1 tests the terms in a fixed order, so that one main effect is tested on its own, the second main effect is tested adjusting for the first, and so forth. Because this results in main effects that do not adjust for each other, only one of them is adjusting for the other one, I recommend never using this approach, as most psychologists will find it highly counterintuitive. However, this is what the lowercase a ANOVA function from base R does, and that's why I recommend never using that function to get anything that you might call an ANOVA table. Use it only for comparing two models at a time. If you want an ANOVA summary table with main effects and interactions in the same table, use the A ANOVA function from the CAR package. The terms type 2 and type 3 are a real nuisance. They confuse people and they clarify little. If you are comfortable with linear regression models, with the stuff that we covered before we got to today's topic, you can always just describe those models directly and avoid having to refer to type 2 or type 3 at all. It is often helpful to use the A ANOVA function from the CAR package to get reasonable type 2 main effects without having to set up several regression models. So it's nice to have at least had this background about what that function is really doing so that you can use it as needed in the future. In this session, I've relied on examples featuring one two-way interaction and two main effects. These ideas generalize to more complex models, but it works best with the example if we focus on the simple models. For example, if you have a three-way interaction, then there are multiple ways to define the overall two-way interactions, corresponding to the multiple methods for defining overall main effects that I described earlier. And there are still multiple ways to define the overall main effects as well. Also, all of the methods, except arguably type 3 with contrast coding, generalize to interactions involving numeric predictors as well. So they don't have to just be used with categorical variables, although there is a strong norm that we use them only with categorical variables. I want to end with a reminder that you don't necessarily need any of this. ANOVA is just a framing device for regression. And if you understand the regression stuff from the previous several video series, you're pretty much set. When in doubt, just focus on the regression models and don't worry about calling it ANOVA. If you need overall main effects, you can just take the interactions out of the regression model. If you want a quick way to get overall tests of lower order terms in an organized table, then you can use the A ANOVA function from the car package with its default type 2 setting. And don't worry about type 3 unless you really want to worry about type 3, or unless you need to compare to SPSS.